Right, so good morning, everybody. Right, today we're going to continue working on lesson 5, which is problems with inequalities. We started that one yesterday, and again, you guys working through it yesterday, so today is just going to be me going over those last couple of slides pretty quickly and just answering any other questions that you have. Then at the end, like I said earlier, we're going to go ahead and play a quick game of Cahoots. Right, so I know I left you off yesterday on this slide over here, where you're going ahead and just answering these questions. So if anybody was stuck here, has something that they want me to go through really quick, just please let me know and I can go over that. Otherwise, I'm going to continue on to start looking at the rest of these slides here, okay? I think we've only got about maybe 4 to 5 slides to go over, so it should be pretty quick. All right, so over here, they're just kind of giving us another couple of examples to see some real life examples, they like to call it, of how you can apply inequalities to your everyday life. So if for some reason, you ever need to buy business cards, this is something that might be relatable to you, right? So it says here, Greta needs to get 15 packs of business cards, right? So if anybody doesn't know what a business card is, basically when you have your own business, you'll have a small little index card that you give to people that has like your name on it, your phone number. And if you do have a large business, this is something that people would actually buy, right? So you're gonna get 15 packs of business cards. And down here, she's looking online and she has a couple of different options of what types of business cards she can get. So she can get one that's glossy, that means shiny. One that's matte, that means that it's not shiny. One that's textured, I think we know what that means. And then a regular, right? Because she wants to be basic. So the idea here is that she has a limit on how much she can spend, right? She actually can only spend $200, but remember, right? She needs 15 packs of business cards, right? So this piece of information here, plus this piece of information here, how much she can spend, is actually gonna tell her how much money she can spend, right? Or which of these she's actually gonna be able to afford, right? So what they did for us here is they actually already set up an inequality here. 15C is less than 200. And just really quickly, I just wanna make sure that we understand where they got that from, right? So again, pretty simple to figure that part out. We know that she needs to buy 15 cards, right? Sorry, 15 packs. And what they're saying here is that C is gonna be, sorry, okay, there it is. C can be represented by the, sorry, this doesn't make sense. The number of cards you can be printed. Yeah, C here is gonna end up being the cost, right? I think that looks like a typo to me. She needs 15 packs. C represents how much it costs. And when I multiply these together, right? So let's say she bought 15 boxes, they cost $10 each. That would be $150, right? So she needs the total cost to earn $200. So it's really important to just understand where each piece of an equation or an inequality is coming from. And that's gonna help you guys to just figure out, and understand better what everything means. So basically what we're doing here is just like we did yesterday. You would just be substituting values in to try and see which ones work, right? So if she went with the glossy card, plus $10, I'll just go over the first example and then the rest are given to us there, right? We would say, okay, so let's say she wanted to buy this one. So she needs to buy 15 boxes at $12 per box. So 15 times 12 is gonna cost her $180, right? So $180 is less than $200, so she's under budget. So she can't afford to buy the glossy cards, right? Now, if you look down here, it actually gives us all the work so we don't have to redo it all. And we can see here, if she bought the $16 ones, those are too expensive. She can't buy that. Also, if she were to buy this one, it ends up costing $270, 15 boxes at $18 each. The bottom one, if this one worked, this one was $12, this one is cheaper, this one, right? We definitely know that that one is also gonna work because it's cheaper than the glossy cards that she already knew that she could afford, right? So a good thing about math is that when you start thinking about things a little bit more instead of just, blindly substituting the numbers in and trying to do the math, just think like, can this work based on what I've seen? So if this one worked, it should be have to work as well, right? This is a different example, right? So this example here is talking about an orchestra. So the members of the orchestra are organizing a benefit concert to spread awareness about Parkinson's disease. The concert will be held in an auditorium that can seat 100 people. So numbers are important. Again, anytime I read a word problem, I usually try to underline or highlight whatever seems important. So 100 people are going to the event. They need to try to raise this much money. Again, something else is important, right? Actually, what it says here is something that's important. It says they need to raise more than 7,800. So actually, let's highlight all of that, not just the number. So us that we're dealing with an unequal. If everyone's going to mute me for a second, seems like its background's a little loud, right? If instead of it said they need to raise more than $700, right? If it said they need to raise, and we take this part out, $7,800, that means we're talking about an equation, right? That means that instead of having, they give us the expression here, 100x is greater than 7,800, I would have an equal sign, right? But because they say that they need to raise more than, that's a big key hint that you're gonna need an inequality, right? Because they could raise $8,000, they could raise $10,000. They need any amount that's higher than that, right? They don't only need that amount. And when you're talking about math, those facts become really important, right? So it says here the different options for the ticket prices are $72, $75, $78, $80. How much should they charge in order to make sure that they get their target of, again, over, right? Over is another way of saying more than $7,800. So pretty easy to figure out. 100 people, so they're gonna sell 100 tickets, and in this case here, X is gonna represent the ticket price. So if you're buying 100 tickets at X dollars each, that's where this comes from here, right? So 100 people, that's where they got this 100 from. And my pen is not, well, there we go, some lag again today. $100, sorry, 100 tickets, X dollars each. So all again, just like the last example, we just need to multiply them. So again, they did the work for you over here. So if you were to substitute the 72 from here into this X, 72 times 100 is 7,200. They're not going to make enough money. If they did it for $75, again, they're not going to make enough money. And the numbers are nice enough, especially since you're dealing with 100, that it should be pretty easy to see, right? Again, like yesterday, I went over an example like this. This is the kind of case where you need to be careful. If they sell the tickets for $78 each, they're going to make $7,800. But it said they need to make more than $7,800. So $7,800 isn't enough, right? They need to make, in that case, at least, you know, like maybe $7,801. Or maybe, you know, it would even work if we had something like $7,800.01, because they need to have more than 7,800. So if they make exactly that amount, it's not enough. So the first case that it shows that works is if they charge $80 per ticket, that gets them to something that is in fact larger than $7,800, right? So any questions on that slide there? Let me just check the chat real quick. All right, so last slide here is just an example for us to go through. So I want to give you guys a minute. Actually, we'll say 2 minutes to try and work this out. So I'm going to set the chat just to host only. When you get the answer, message it to me here so I can see it. I'm going to set a timer for 2 minutes. And all we're doing here is trying to figure out what value of n is going to make this inequality true. So all we have to do here, right, remember, is substitute values in. So just to show you in case you don't have an idea, is I would take this 16, substitute it in here for n, substitute it in, sorry, here, where that 2 went, so it would look something like 7 times 16. Is that greater than 75 plus 2 times 16? Here's the timer in case you can't see it. We've got about a minute left. That's correct, Jinghao and Jaden. You got it, Sissy. Good, right. So ideally, some people did it yesterday. Maybe try checking the math on that. Okay, we're out of time. Anthony, you also got it right. Okay, so a couple of people got it right here. Now, all right, Bella, I'll try to help you out with that after we finish this. We've got like 2 slides left, okay? So a couple people got it right. It is 16, right? So this first example that I actually gave you here, turns out that it happens to be correct, right? So again, we've got a calculator right here. So all I would need to do is check the math and say, okay, so does, 7 times 16, that gives me 112. So I see 112 is greater than, remember order of operations, we need to multiply first here. So is that bigger than 75 plus 32? 75 plus 32 is going to be 107. And then we just remember, look to see which way is Pac-Man's mouth facing. It's facing the bigger number, so that's true, right? So again, sometimes when you're doing multiple choice, you might pick it and get your first answer correct, right? So good to the people that got it. If you didn't quite get it, hopefully you can see how we work that out. And if you went ahead and tried all the other ones, you're going to see that they don't work, right? So let's say I tried 10 just really quickly. That would look like 7 times 10. Is that bigger than 75 plus 2 times 10? 7 times 10 is 70. Is that bigger than 75 plus 20? No, it can't be, right? Because 75 is already bigger, so if I add to it, definitely not. And then you might reasonably think, okay, so this number didn't work, so neither will this one, neither will this one. I need a bigger number, right? Smaller numbers aren't going to do it for me there because I need something that's going to end up being bigger than kind of that 75 term up front, all right? So let me just check the chat. Right, so the bigger one is always going to be where that mouth is facing, right? And I think we're already up to the summary slide, right? So let's just summarize really quick, just talk about the key things that we talked about today. So remember, we see that inequalities express a comparison between 2 values. We use less than, we use greater than. We also use less than or equal to and greater than or equal to, right? So the inequality, all right, I'm not going to bother rereading this word for word because I think most of it's pretty straightforward unless we have any questions. All right, I'm going to put the chat back in a second, right? And a key thing, I think one of the most important things to remember is down here, is that an inequality can have multiple solutions, right? Equations usually have one solution. Inequalities, we actually say, have infinite solutions, right? So like looking at that example that we just saw on the last page here, we saw that 16 worked, right? We can check. Bigger numbers are going to work. 17 is going to work. 20 is going to work. 30 is going to work, 100 is going to work. So any number that's larger than 16 is going to end up working for us there, right? And that's kind of the main thing to remember when you're dealing with these inequalities, right? So we're done with the actual live lesson for today. So what we're going to do next to review is actually we're going to play a game of Kahoot that involves inequalities, all right? So I'm going to stop the recording for now.